Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on buck converter. First here buck converter definition. So buck converter is a type of DC to DC converter, that means chopper, that step down means here higher voltage is the input voltage and lower voltage is the output voltage. So now here Vs is the supply voltage and V0 is the output voltage. So supply voltage is greater than and V0. So this condition, supply voltage is always greater than the output voltage. So it is a Vs is the supply voltage and V0 is the output voltage. Here step down voltage, output voltage, this is DC to DC converter. So now here this is the circuit diagram of buck converter. In the buck converter, so here we are using one switch, so that is SW, and here this is inductor, and here one capacitor, and that one diode we are using. So now here in this buck converter, first when switch is on, find out IL, inductor current, and this is VL and this is VL, inductor voltage and capacitor current. And when switch is off, inductor voltage and inductor current. And next volt second balance, that equals to VL on T on plus VL off T off. So that equals to 0, that we will discuss. And same way, so ampere second balance means IC on T on plus IC off T off. So first calculate the VL on IC on when switch is on, and next when switch is off, calculate VL on and VL off and IC off. So here T on means that is dt, d is the duty cycle, and T off means here that is 1 minus d t. So T on plus T off equals to total time period. This is the scenario. And next, ripple in the inductor current del IL, next IL maximum, IL minimum, and source current IS, and switch current ISW, and diode current. So this is average value and RMS value. Same way, average value and RMS value, and ripple in the capacitor voltage. So del VC, and duty cycle ripple is maximum. So now delta equals at what delta value the ripple is maximum, and critical inductance and critical capacitance. Here, so first when switch is on, find out the VL minus. So VL and IC, inductor current and inductor voltage. So here when switch is on means it is closed circuit. So when it is closed circuit, this is open circuit. There is no current, so it is in reverse bias. And next here calculate this VL and IC. So here if you apply KVL, here if you apply supply voltage and current flows through this switch is closed, and when switch is on, current flows to the inductor, and here this is V0. So now here when you give the supply to this switch, here current flows in the inductor, so inductor stores the energy, and when you switch off it, so that is charging. Here this is charging. When you switch off it, it acts as a current source and it will discharge through this freewheeling diode. So now here, so when VL, and how we will calculate if you apply KVL in this loop. If you apply KVL in this loop, Vs equals to VL plus V0. So VL equals to Vs minus V0. So now VL on equals to Vs minus V0. So this is the case. So when you apply KVL, so KVL means this is open circuit because it is plus and this is minus, it is cathode and it is anode. It is in reverse bias, it will be open circuit. So that path is So voltage source, this switch, this inductor, and this capacitor, and this one. And now here, if you apply KCL at this node, here IL equals to IC plus I naught. So now here IC equals to IL minus I naught. So now here IC on equals to IL minus I naught. So these are the, when switch is on, so calculate the VL and IC. When switch is on, calculate the VL and IC on. So these are the formulas. Now calculate when switch is off, calculate the VL and IC. So switch is off means it is open circuit, it is in forward bias. And next, if you apply KVL in this loop, and now here this is 0 equals to VL plus V naught. So now VL equals to minus V naught. So now VL off equals, this is in off condition, that equals to minus V naught. That is minus V naught. And next, if you apply KCL, same current, IL equals to IC plus I naught. And next, IC equals to IL minus I naught. So now IC off equals to IL minus I naught. So these are, when switch is on, that in that case VL and IC, same way when switch is off, for that case VL equals to minus V naught and IC equals to IL minus I naught. So now here volt second balance, here volt second balance means VL on, T on plus VL off plus T off. So that equals to 0. So now here VL on means Vs minus V naught into T on means that is dt. So this is dt and this is 1 minus dt. So total time period is t. So now here, so that equals to plus, this is minus V naught, already we calculated, this is 1 minus d into t equals to 0. So from this you can calculate the output voltage. So now here, so Vs into dt minus V naught into dt. So minus V naught t plus V naught dt is equals to 0. So plus V naught dt and this minus V naught dt gets cancelled. And next Vs dt is equals to V naught t, dt gets cancelled, V naught equals to d into Vs. So now this d value is in between 0 and 1. So now here 0 and 1 means output voltage is always, Vs is always greater than V naught. So here voltage is step down in. So this all output voltage always between 0 to 1. So now this is the case for buck converter. Duty cycle equals to D equals to V naught by Vs. Now here ampere second balance. Ampere second balance means IC on, T on, IC on, IC on plus T on plus IC off, T off is equals to 0. IC on means IL minus I naught dt, this is dt plus IL minus I naught, that is also same, T off, that is T off means that is 1 minus T dt, 1 minus D dt equals to 0. So now here same common, if you take the common, IC minus I naught equals to 0 and next IC equals to I naught. This is the conclusion. So not IC, IL equals to I naught. Here inductor current IL equals to, inductor current IL equals to I naught. So this is the condition. In the output current equals to, average inductor average current. So that is, now here this is IL maximum, and this is IL minimum, and that IL maximum and IL minimum, that is del IL. So now here this is the del IL del IL by 2, and this one is a del IL by 2. So now here ripple in inductor, you need to calculate. This is the IL maximum, IL minimum, and next IL average, that equals to I naught, and this is the del IL, this is del IL by 2, del IL by 2. So now how we will calculate? So we know the formula L di by dt equals to, that is voltage. So that voltage equals when inductor is on. So now here, so that is supply output voltage equals to Vs minus V naught. So now here this IL on. So now L, so del IL when inductor is on. So now here the on means that is that duty, that on condition, that time duration is dt, that equals Vs minus V naught. So now here what will happen? So now del IL equals to, so 1 by T indicates, so that is D into, so Vs minus V naught indicates D into Vs into next again dt by L. So now this one equals to D into 1 minus D into Vs by, well, T indicates 1 by F, L into F. So now here final formula, so that one is equals to DIL equals to D into 1 minus D into Vs by LF. So this is the ripple in the ripple in the inductor current. So ripple in the inductor current, LF. So now here if you calculate the IL maximum and IL minimum means, so I naught plus DIL by D2 means IL maximum, and I minimum means that is I naught minus DIL by DT. So now here IL maximum equals to IL, this one equals to IL means that is output current plus, so delta IL by 2. So if you substitute this del ripple in the inductor, so substitute in that, you will get the answer. Same way that one equals to IL minus del IL by 2. So IL minimum and IL maximum. So this is del IL. So del IL by 2. So this is I naught or IL. So now here this is del IL by 2. Now here source current. How we will calculate the source current means, here we know the power input equals to power output. So power input equals to power and output means Vs into Is equals to V naught into I naught divided I naught. So now here Is equals to Vs into Is. So now Is equals to V naught into I naught divided by Vs. So we know the formulas for V naught, I naught and Is, and V naught means D into Vs, I naught means V naught by R by Vs, and same way D into Vs. Substitute in this D into Vs by R, like this you substitute in this, you will get the source current. So this is the case for source current. So now here what about the switch current? Switch current is different and source current is different. So source current equals to switch current, but source current equals to switch current, but here switch current when is turned on only calculate the value. So this is the total current. If suppose this is the total current, so source current. So now here turn on case only you calculate that current. So now here turn on condition, so that equals to ISW equals to, so that I naught or IL. So I naught or IL into dt by, so this time duration is dt by total time duration t. So that equals to I naught or IL into d. So I switch current. This is average current only. Average current only. If we calculate the RMS value equals to, this is average only, ISW. RMS equals to I naught into square root of, so dt by t, that equals to I naught square root dt. So ISW RMS. So when switch is on condition only, source current you need to calculate. And now here diode current means when switch is off. When switch is off, okay, so this duration only. So now this is total time period. So now when switch is off, this diode will conduct. So diode in forward bias. When switch is on, diode in reverse bias, there is no current. So now here turn off time duration, that source current is the diode current. So here, so ID average equals to same inductor current or output current, that equals to I naught or IL into, so what about this one, 1 minus D total time period divided by total time period, that equals to IL or I naught 1 minus D, 1 minus D. So this is the ID average. So now here what about ID RMS? RMS equals to same I naught square root of 1 minus dTd by T. So that equals to I naught square root 1 minus D. So ID RMS. So this is the case for buck converter, diode current average value and RMS value. And next here, ripple in the capacitor. So ripple in the capacitor means here, so this is the IL average and this is for IC. So for IC current here, now here there is a formula for Q equals to C. So Q equals to CV. So that means delta Q equals to, that is C into delta V. So now here delta V equals to delta Q by C. So now here what do you mean by delta Q equals to? So now this is IC, here IC equals to IL minus IC. We know this formula. IL minus I naught means I, this one. So now here from this you minus this one, you will get this one. So now here in this case this is the T by 2 time duration. This is the del IL by 2. So now here this is the charge that equals to del Q equals to 1 by 2 of into B into H, 1 by 2 T by 2 into del IL by 2. So that equals to del IL by 8 into F. T means 1 by F, del Q equals to. So now here, so 1 by del IL by 8 into F. This one. So now here this equals to del IL by 8F means this is D into 1 minus D into Vs by 8F, so as it is in the denominator in the L into F, that equals to D into 1 minus D into Vs divided by, so 8F square L. So now that is ripple in the capacitor. So again here there is a C and this C, and now here this is C and this one is a C. Now this is a formula for del Vc. And next here another one, at what duty cycle the ripple is maximum. At what duty cycle at the ripple is maximum means you need to derive with respect to T. So now here, so 8F square LC, so D into 1 minus D into Vs, that is Vc is equals to 0. You need to derive with respect to D, dVc by with respect to dt equals to 0. If you do this one, so D into minus 1 plus next 1 minus D into 1, that equals to 1 minus 2D is equals to 0, that equals to D equals to 1 by 2. At duty cycle D equals to 0.5, so the ripple in the capacity in the ripple voltage ripple is maximum, so that value equals to 1 by 2 into 1 by 2 into Vs by 8 into F square LC, that equals to this value equals to, what is the value, 1 by 32 into Vs square L into C. This is ripple. When ripple is maximum, so the ripple voltage or voltage ripple is this much. And if you calculate the what about if you calculate the ripple current equals to same D into 1 minus D Vs divided by um, yeah, F into L. So that is del IL. So that equals to 1 by 2 into 1 by 2 Vs by Fl, that equals to Vs by 4Fl. So now here this is for rippling capacitor when maximum D equals to 0.5, D equals 0.5. This is the maximum ripple current voltage. This is a maximum ripple voltage. And next here critical inductance. So now first define the critical inductance, the minimum inductance for which so the inductor current becomes just continuous. So that is ripple critical inductance, that is L equals to IL. L equals to LC equals to, you need to calculate. So we know the formula. So IL minimum equals to, IL minimum should be is equals to 0. IL minimum is IL minus, IL minus. So now here del IL by 2 equals to 0. So now here IL value means, here IL means I naught. I naught equals to del IL by 2. So now here del IL means already D into 1 minus D into Vs by, so what will be the, this one is the F into L, and there is a again 2 is your, and next here V naught equals, this is V naught by R. So here what about V naught means here, so D into Vs divided by R. So this Vs and this one is gets cancelled. This is minimum critical capacity inductance, and LC equals to here, so 1 minus D into R, 1 minus D into R divided by 2 into F. So this is the critical inductance formula. So critical inductance definition I am again giving you. So first, what is the minimum inductance, so for which the inductor current becomes just continuous. Same fashion for here critical capacitance. So here minimum capacitance for which the output voltage the V naught just become continuous. So now here V minimum equals to, so here V minimum equals to del Vc minimum equals to 0. So now here V naught del Vc equals to 0. So now here, so that value equals to V naught equals to V naught equals to V naught equals to del Vc equals to 0. So now here V naught equals to, what is the value of this one here, D into 1 minus D into Vs. So that value equals to divided by 2, that equals to 2 into F square into LC. Here C L into, this is critical capacitance. So now here this V naught equals to, what is the value here? Here V naught equals to, this is this one and this one is a V naught. So V naught equals to D into Vs, it will get cancelled. And next here this is CC equals to 1 minus D divided by 16 F square into L. So this is the case for critical capacitance. If you substitute that this one equals to, so 1 by D 16 F square, this is critical capacitance 1 minus D into R by, so that equals to 2 into F, that equals to 1 by, so this one gets cancelled, so 1 by 8 F R. So this is the case for critical capacitance. So now here we have derived all the formulas. So now here first one equals to VL on, VL off. So VL on means Vs minus V naught, and this one is a minus V naught. Sorry, this is minus V naught when switch is off. IC on equals to VL equals to, this is VL equals to, and IC1 equals to IL minus I naught, and this one equals to, in this case also, IC of equals to IL minus I naught. This is on condition VL and IC. This is off condition VL and IC. Volt second balance we calculated from this. So Vs equals to D, V naught equals to D into Vs, and next volt second balance IL equals to I naught we calculate. Ripple in the capacitor inductor means D into 1 minus D into Vs divided by del IL, that equals to F into L. So now that one equals to, and next here IL plus del IL by 2 and IL minus del IL by 2, and source current equals to I source current equals to V naught I naught by Vs, that equals switch current equals to, so IL or I naught, so that equals to D, that is average current, and I naught square root D is the RMS, and next I naught square root of D, 1 minus D is the average value, and next here I naught, so that equals to I naught square root 1 minus D. So now ripple in the capacitor, that equals to, so del Vc equals to D into 1 minus D into Vs divided by 8 F square into Lc. So now here at what duty cycle? At 1 by 2 duty cycle. So here at D equals 1 by 2, the ripple is the maximum. Now here critical inductance equals 1 by Lc equals to, that is 2F into R, and next ripple in the capacitor is equal to 1 by FLR. So these are the formulas most important while solving the buck converter problems. I hope all these problems are clear to you. If you still have any doubts, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.